How everyone doing? You made it to the last session of the last day? Right, that's the energy. Come on. Promise you will not make this a boring session. It'll be fun and you will have something to take away. Cool. With that said, we are 3 speakers today. My name is Sita, and I'm a developer relations engineer at Google Cloud. In my previous life, far long ago, I was a machine learning engineer. Back when classification and clustering used to be the cool things. Anyone remembers? Yes, I see hands. And then I transitioned into cloud security, and now I bring the best of both worlds to build secure, production-ready agents, and that's what I do. And I have 2 wonderful co-speakers here today, Kanchana Pattola, my colleague from Google Cloud, and Siddharth Jain from FordCredit. And together, we are going to walk you through this agenda. We'll share key principles with you, architectures and best practices for building production-ready AI agents. And Siddharth then will share how FordCredit brings these AI agents to production. But before we go into the session content itself, I want to take 30 seconds of your time to set the gravity of the situation we are in. I know most of you already realized this. The way that we build software from last year to this year has changed, right? Rapidly, and even the way we consume software. Tools and protocols that did not exist last year do now, and that's becoming more mainstream, which is what we'll be focusing in on the first section. If last year was about building these agents, this year is about building systems around them so we can bring these agents into production in a resilient, robust, and secure manner. And I'll be focusing on building components of the agents that would go into production. And with that, let's start with the first segment of the session, which is path to production. You might have seen these boxes and slides. Don't worry, I'm not going to make you read them. It's a lot of boxes. And I promise I won't read them to you all. It's not going to be a catalog walkthrough today. Instead, I'm going to wear my engineer's hat and share with you all 5 key principles that we have learned from deploying and building agents in prod. And if you have to take away one thing from this slide, it would be we've broken down the agent development lifecycle into 4 buckets. You have to build them, scale them, govern them, and optimize them. That's it. With that, let's go into the first principle here, which is jump-starting your agent building. Just like we have different personas in your organization, like few of them could be coders, few of them are subject matter experts, few of them in between, there's no one tool that fits all when you're trying to get more people to adopt and use agents to improve their productivity. If someone is a subject matter expert who doesn't code, then we can give them a visual canvas like Agent Studio to build, drag, drop components, build agents, and when they're ready, they could export it to an agent framework and share it with your engineering team. And if someone is in between, if they're coded but not that much, then Agent Garden could be a good starting point. We have pre-built enterprise-ready samples that they can click deploy to agent runtime or Gemini Enterprise and share it with your org instantly. But what if someone is a hardcore coder? That's where a framework like Agent Development Kit comes into play. So for those of you who haven't used ADK, ADK is Google's homegrown agent development framework. It comes with a host of primitives that you want for production agents, like support for complex graphs, support for human-in-the-loop, event-based triggers, code sandbox, etc. And to jumpstart building with ADK, we have launched recently Agent CLI, which is a programmatic interface, a CLI tool for building, evaluating, and deploying ADK agents to agent platform. But these are several different options, right? But the underlying principle stays the same. Provide the right tools to the right people to enable them to onboard to building agents. With that, we go to the second principle, which is once we've built the agent, the next thing to think about is how do you build tools around it? How do you give your agent skills? Apologies, I have a bad throat. And these principles are not something that we are inventing new. These have been forever from the microservices concepts, right? But how we apply them to agents is what's different. And I want to talk about 3 things under separating the concerns: MCP, A2A, and skills. MCP is a way to abstract your agents from your tools. Think about this. When we were building agents last year or the year before, we write a Python code to call an API or a third-party database. But let's take a step back and think what happens here. We're tightly coupling our agent with the tool. What happens if an API schema changes, if the database changes? We are in no control of agent code. We have to rebuild it again. We have to make changes. But this tightly couples our agent with the tool, right? So what we do is we instead could adopt MCP as an abstraction layer in between. So your agent can talk to the MCP server, which then talks to the endpoint. So virtually isolating your agent from external dependencies. And second is the same for A2A as well. When you want your agents to talk to other agents in your organization, we ideally shouldn't be writing these integration pieces of code that no one wants to maintain. Instead, we could use A2A protocol that would hand over the task to the other agent, delegate it, and get back the response, thus creating a second separation of concern. And the third one is agent skills. And now skills is a hot topic that's going on, right? So skills is nothing but a markdown text file, but it's so powerful. It has rules, it has your business rules, your data, your resources, everything packaged into one markdown file. But what's different is, when longer context windows came for LLM, we started putting all of our business rules and constraints and everything into the context window, and this blew up our context window, but also the latency, the cost, the accuracy. Like, everything took a hit, right? So skills is a way to separate that concern. You're packaging all of your custom rules and providing it to your agent so that the agent can load it on demand and not always. In summarizing the second principle, whether you adopt MCP, A2A, or skills, the concept is separate your agent's reasoning and engine from whatever could affect it. Optimize for latency, optimize for cost, optimize for context. Which now makes us go to the third principle. Well, before that, I have a slide which I forgot conveniently. ADK provides all the native support for MCP, A2A, and skills out of the box, and more. If you're building with ADK, it has some good stuff, and I recommend you to check it out. And so far, we've seen how to jumpstart building. How do you build tools around this? So the next one is scaling the agent. What happens after you build? What are the decisions, build versus buy decisions, that you have to make, right? So the 2 important choices that we have to make here are, what is the strategy for short-term and long-term memory? What is the strategy for runtime? Where are we running this? Without sessions, each conversation with your agent is a new message. The agent has no recollection. It has no short-term memory. And without long-term memory, your agent doesn't remember what happened 2 days ago. There's no context for it to retrieve. But before we go down the route of building these short-term and long-term memories, we should take a pause to understand, does my agent really need memory? Not all agents do. If you're building a simple lookup agent or a simple stateless agent, then memory is an overkill for the agent. But if you do decide context matters for what you're doing, then we're looking at 2 paths. The first is the retrieval augmented generation, or RAG, which you're all familiar by now. It's been around for 2 years. And this involves building complex RAG pipelines to implement long-term memory. If you have a niche use case, or if you have compliance-based requirements, then this path makes more sense. But if you want something out of the box, if your differentiation is not your memory for what you're building, then you could use agent platform sessions and agent platform memory bank, which are short-term and long-term memory solutions that are provided by agent platform. So for agent platform sessions, we are looking at 365 days of default TTL, short-term memory available on demand, and it is auto-provisioned for ADK agents that are deployed to agent runtime. And for agent platform memory bank, this is a ready-to-use vector database with a semantic search. And it is asynchronous, meaning it works in the background when your agent is doing the task, so there's no latency compromise there. And you can also customize what information your agent remembers and also your TTLs. And both of these, again, are natively supported and wired to Agent Development Kit. Which then brings us to the next important decision we have to make in scaling, which is, where do we run this, right? There are several different options, including localhost, which I've run many of my applications at. So when we choose a runtime, we always weigh it based on the basics, right? The infrastructure, the scaling, flexibility, cost. These are great parameters we choose. And this should still remain. But additionally, when we're building agents, we might also want to look at, does my runtime support human in the loop? Does my runtime support long-running operations that my agent might need? What does the integration with memory, security, and guardrails look like? Like, does my runtime offer native integration, or do I have to build it? And our recommendation is, if you are starting to build agents, and you want most of the features built in, like memory and security, you can start with Agent Platform's runtime. Agent Platform runtime now also supports bring your own containers with a long-running TTL of 7 days. But if you're a fan of Docker and you like portable solutions, then Cloud Run is an option. And move to GKE only if you have a massive, high-traffic swarms of agent fleets that we're maintaining. The key is to not over-engineer our runtime before there's an actual need for it. And the pro tip that we've seen many customers use is to deploy their agent and reasoning in agent runtime, but the MCP tools is part of Cloud Run, and still maintaining it nimble and separation of concerns with both these. The key here again in the third principle is, no matter whatever you choose for your sessions, your memory, or your runtime, build the logic and not the glue work or the plumbing around it. Like, weigh your trade-offs. What are your P0s? What is your strategy for build versus buy? And what are you willing to compromise and build? Which brings us to the fourth principle, and my favorite, which is govern through infrastructure and not prompts. Agent governance is not a prompt engineering problem. We can't just write in a prompt saying, you're a helpful assistant, please don't delete my database. Yeah. I've been a victim to it too. I've tried it. It doesn't work. It may work a few times, but not every time. And which is why we advocate for governing through infrastructure. And there are three classes of problems which we have to think about here. First is visibility. What does my agent have? Like, what does my agent and tool domain look like? Like, what are the things that are available in my domain? Second, control. Like, what does my agent and tools have access to? How do I scope them? And third, security. How do I proactively detect malicious rogue agents? And Agent Platform answers this through our new and existing launches. So agent identity is our spiffy-backed ID that gets automatically applied to every agent that's being deployed to agent runtime, GKE, et cetera. You just need to enable a couple flags. And agent identity actually also supports auth providers, meaning it automatically manages your OAuth 2 and API keys, so you don't have to write these refreshing your token logic. And second, we have the agent registry, which is actually a single pane of glass for all of your agents and tools that are in your domain. And you could also additionally bring agents and tools from external third-party services. And third, we have agent policies, which are the way to scope your agent's permissions. Like, you have IAM policies and natural language policies that you apply to your agent. And fourth, we have agent gateway, which is a single governance layer on top of all of your agents. So it sits between the ingress and egress pathways from the agent, monitors the traffic, and can enforce these IAM policies and principles. And together, it looks something like this. Agent identity in the center, agent registry, security, and authorization policies all flows through the gateway. Cool. Let's go to the final principle, which we have: always observe and never assume. So agent observability and evaluation go hand in hand. We can't just look at an agent's output and say, it looks good to me, right? we need logs, traces, metrics, and all of these capabilities are supported by the products that you see on the screen here. And agent evaluation is the other side of the coin, where we're not just testing for the agent's output, but we're testing for the agent's trajectory. Did my agent do the right thing? Did my agent take the right path to do the right thing? And these metrics can be human-defined, can be LLM-defined, et cetera. And 3 services that I want to quickly call out before handing it over to my colleague here for the next session is you can evaluate pre-production using our synthetic data generation capabilities, which we have newly launched. This is called Simulate Your Session. So this has the capability to synthetically generate production traces that you can run against your agent before you deploy it to production. Which brings us to the conclusion, and this is the culmination of whatever we've been discussing so far. You see the agent at the center with an identity, which is deployed to runtime, and it is also registered to the agent registry there. And all of this IAM policies are governed by agent gateway, which you see in the red box there. And finally, we have the observability and evaluation. To recap, these are the 5 principles we saw today. Jumpstart your agent building, separate your dependencies from your agents, focus on what are your build versus buy decisions during runtime and memory, govern through infrastructure and not with prompts, and always observe and evaluate. Thank you very much. And I'm going to hand it over to my colleague to focus on deep dive into building your agent and what are the decisions you have to make when you do it. Thanks.
Thank you. That was great. Thanks, Sita. Hi, everyone. So Sita walked through the components of building an agent and taking them to production. My focus is going to be what are the decision points or questions or challenges or things of that nature when you are taking it to production. I first want to, this is an agent that was built internally in Google, and my team built it for documentation purposes. The reason why I bring this up is I live this journey. I live the journey of how production agents are complicated it's easy to build a prototype, but it's super hard to get it into production, and I understand that. And as a product manager for Agent Garden, I also talk to close to 10 to 15 customers a week. Every week, I hear problems of pitfalls, challenges, so I understand the space we are in. When Sita walked through the agents, the tools, the models, all of those, that's a powerful engine. We know it is a powerful engine because of the capabilities it exists. But it's not a car to run till you have a dashboard, till you have a brake, till you have a transmission. And the focus or the questions I'm going to walk you through today is driving you towards what are the things which you need to be asking in your organization. The first thing I want to walk through is the personas of in an organization who are available. The builder. Notice my word of a builder. I'm not calling them as a developer. The builder today can be a developer or a non-developer, so it doesn't matter. The builder, what do they care about? They care about prototypes. They want to make sure it's quick. They want to be able to show the powerful agents. They want to evaluate. They want to understand what are the weak spots in their, the agent that they have built. And then there is the operator who cares about connecting to their data, deploying it, fixing it to make sure if there are any problems. And we have the admin. The focus shifts from running an agent to governing and policy making. While the operator asks, is it working? The admin asks, is it safe? Is it compliant? Is it cost effective? So in your organization, these are the 3 personas you would be working with on agents. So together now, we are going to walk through this use case, which is probably in your enterprise. You have this as part of your security team or something. But we are going to build it together. And I'm going to walk through with you the questions which we need to ask as we build this use case. So it's a Cyber Guardian agent we are building. It's not a chatbot. It's not just answering questions. It's triaging, it's investigating, it's neutralizing, so it's taking action. All of those are the agents which we are going to build it. So zero, the basic question, who is building? Because in your organization, maybe there is a SecOps lead who is very comfortable in building a low-code agent, like for triage flows and et cetera. And they probably are very comfortable with it. Or there is a security engineer who's very pro-code, and they're building MCP tools, et cetera. So in Google Cloud, I'm sure you probably have, in the last 2 days, seen some of the, all of these demos. The leftmost is the business user who can build it using Gemini Enterprise app, Gemini Enterprise for CX, or a developer pro, which Sita walked through with Agent CLI, Agent Runtime, Cloud Run, GKE, all of that. The first question is, who are you building for? We have been this journey. Like decades ago, computers only talked binary code. And then there was, command line interface. And then we had a GUI interface. And then now we are in a conversational interface. So we have been through that journey. But we have always built for human users. But in today's world, we are building for agent users as well. And that is a clear distinction. And why does it matter for a Cyber Guardian? Because for Cyber Guardian, it doesn't wait for a human to type. You want an alert that comes in, and the agent should take action. So human is not in the loop. It is taking an action by itself. I hear you probably are thinking, oh, we have always done that. My service A calls service B, and it has always worked. This is not new, is probably what you are thinking. But in an agentic world, it's different. They get a natural question, secure this endpoint, and then it determines what the path is based on the context of the threat of that situation. That is completely different from a deterministic workflow, which you have always set up. And if you look at the left side, which is essentially we had a user interface chatbot, and you probably set up home, profile settings, et cetera. But in the future world, the world where agents are the users you're building for, which is a headless UI, which is coming, you need to worry about confidence score. You need to worry about the reasoning logic. You need to worry about the audit trail. You need to worry about, how do I show that an agent is functioning, an agent is progressing? How do I know I am 92% sure this is the answer, and this is the reasoning behind the answer? All of that is a new user you're building it for. And we are all building through this journey, which is a new agentic UX journey. Next question I often get is, do I need a framework? Honestly speaking, you do not need a framework. You can build a Gemini model with tools, and it is an agent. It is functional. But there are a lot of agent frameworks out there. Why do you need it? For a production implementation, you need a lot of the scaffolding in place for it to be functional. And as a decision maker for a technical debt reduction, you need to care about what are the things which are available out there and I can use. Next question comes to, should I start one? Because when Sita walked through, she walked through an agent. And for our case, it's a cyber agent we are building. And this is actually an anti-pattern. We do not think a God agent is a good way of architecting your agents. But when are the times you can use it in your organization? Prototyping or toy projects. Simple task-specific workflow. You're creating one agent for a specific task, or a low-stake internal, debugging, exploration kind of a thing. Those are the only times I would suggest you build this. Next is, how do I specialize? Because now it comes to, in a multi-agent system, how do I specialize and bring it? In my case, now I'm having Cyber Guardian has 2 agents I'm specializing in, a policy agent and investigation agent. Why should you do this? Because risk containment. You want to make sure the risk is contained to a specific agent, and each of that has its own brain. So you can, debug, explore, all of those things. How do I ensure the agent stays on brand? This is one question, because the most important thing is we know LLMs are unpredictable. So how do you make sure it is going through a journey, or what are the core principles I can go through with? Say for Cyber Guardian, assume it has a right access to everything. You want to make sure it is not crossing any of the core restrictions you can set up. And that's why you would have a guardrail agent. A guardrail is where you specify 10 or 15 core principles of what are the things you want to be deterministic. So yes, your LLM can go rogue, but it cannot go rogue for these 10 points. Then the next question comes to, do we trust the results? Yes, of course, you would do evaluation, all of those which you care about, but a basic bot, say, would report a failure for Cyber Guardian. But in a production-grade Cyber Guardian, assume I want to do a process where it investigates self, and then it determines what the challenge is, and then it creates an outcome. So I create a self-reflection agent. What it does, it understands, oh, I tried this service account, it did not work, I used the wrong service account, and maybe that's what I should correct. So these are things which you should think about including. How do we think about safety? This is another thing, particularly when you're having a code execution or things of that nature where you need a specific agent that does work. So say for our investigation agent is running a Python code, then you need a sandbox environment. That's where you have a ephemeral steel sandbox, which is created for that specific task, for that specific time frame for you to be able to execute and run. Then the next thing is single agent myopia, because we talked all, like if you see my screen, it is all Gemini 3.1 Pro, and I've been using only Gemini. But if it's a high stakes decision, say if you're dealing with $1 billion contract and you are having an agent make a decision, you don't want it to be a single brain that makes a decision. So you create a council of agents. What is a council of agents? It is multiple brains which are debating, collaborating with each other, trying to come up with a consensus before it makes a decision. So you go with a council of agents. Then the next question, now I talked about all of these agents, you know that it is going to be costly. And cost is an important decision, and there are a lot of ways you could save. Like here, I changed the routing agent from Pro to Flash. But that is like the simplest thing to do. There are so many things to do that Cloud FinOps itself is a thing. But if I were to do it, this is the first thing, because I've seen for Cyber Guardian, say if it has GBs of logs it has to process, you don't want to send it through Pro. You could send it through Flash, which is the least expensive model in Google. And you could also use skills, as Sita walked through, so that you're not using the token length. So there are several decisions you need to be talking with respect to cost. So now we talked about multiple agents. So Cyber Guardian is overflowing. And we talked about the self-reflection, guardrails, council, like all of these agents that kept adding up. We know it's a sprawl. We know there is going to be tools, there is going to be agents, all of that happens. So what do I do? That's when you need an agent registry or catalog. Agent chaos is real in any organization. It won't happen in your first agent. It won't probably happen in your second agent. But it is going to happen probably in 2 months if you keep increasing. And the agent registry helps you with your governance, with your auditability, security gap, wasted spend. All of that is where it makes a true difference. So I'm going to walk through all of this in an architecture way. We talked about the users. And this is a layer which you all probably have in your organization. You already have data. You already have observability, CI/CD. All of that should be there. We talked about frameworks and LLMs because we care about them, and those are important. And then we talked about the trust and safety, which is essentially evaluation, self-reflection, guardrails, council. In my opinion, they are the design patterns which you should be thinking about. And last but not the least, the registry and the security, because that's where you are controlling what your agent is doing. So all of these are decision points in your organization as it walks through the building of it. Takeaways. In the last decade, we built microservices to scale our code. In the next decade, we are going to be building agents to scale our reasoning. So you need to, if you were to think about modularity over monoliths, so use specialist forms, deterministic over probabilistic, so make sure you understand guardrails versus chaos of LLMs, and observability over optimism, so do not be optimistic, always be pessimistic in observing your agents. And now, Siddharth is going to walk through how they have made this real in their organization, Ford Credit. Yeah. It does 15 minutes. Okay. We started 5 minutes late, so I was looking like that's fine.
Solve various business problems. Today, I'll walk you through our journey of building AI agents that can survive contact with a highly regulated enterprise production environment. All of you are familiar with Ford Motor Company, but today I'm representing Ford Credit. So while Ford builds the vehicles, our ultimate purpose is to get as many people in those vehicles as possible. And we do that by providing flexible, simple, affordable financial solutions. And given that we are in the financial service sector, we live in a world of strict compliance, high security standards, and zero tolerance for systematic risk. So when we look at technologies like generative AI, we make sure we balance the innovation and the speed with absolute technical rigor. So let's ground the journey that I want to walk you through about bringing production-ready AI agents with a real use case. So similar to many other companies, our product managers have their requirements in Confluence. But for engineers to create those products, they need technical user stories. And that's what creates the blank page problem. The product managers have to start from scratch, which incurs a high cognitive lift. And they have to then convert those high-level requirements into low-level technical user stories. And this creates opportunity for variance in structure and details of the user stories, and also it drains the capacity of the PM. So to assist with that, we introduced a simple user story agent. So rather than PM starting from scratch, the user story agent ingests all the requirements. It understands the context, and it creates the draft stories for the PMs. And the PMs can iterate on it, refine it, and push it to backlog. So we change the role of PM, rather than starting from scratch, to a high value of editing and approval, which brings consistency. So given that we wanted to now build this agent, this basically reflected a paradigm shift if you think from an architecture perspective. And Thomas Kurian on Wednesday reflected on this. The traditional architecture is deterministic. You define your input with a schema, you implement your processing steps, and based on that, you get your deterministic output. It was predictable, safe, and rigid. But tomorrow's paradigm of architecture, it revolves around agentic architecture. Rather than giving it an input, you are now giving it a goal or objective. And the AI agent is going to use all the context and the data available to it to reason through how to achieve that goal, and then it will act on that plan to give you the final solution. So it's adaptive, resilient, and flexible. But that does bring a core tension, because the blast radius of a single user message can be unbounded unless you architect for it. Nobody wants to be in news for their AI agent going rogue. And we have seen some recent stories based on that, like AI agent deleting production database, bringing down live environments, or even deceiving the developers for what it had accomplished. So, and this is the kind of risk that we cannot accept at the enterprise level. And that brings a question, then how do we actually create an agent which is production ready and that meets the high compliance and security standards? So how do we go from POC to production? Because many of you would have seen, like today, if you think about this user story agent, probably someone can build it in a couple of hours if they have the data available. But that doesn't mean that it's ready for production. So in order to deploy these AI agents safely, we had to solve for three things: control, observability, and deterministic testing. Now, I'm not going to talk about architectural patterns which are similar between the traditional architecture, which is deterministic, and the agentic architecture. So things like single sign-on, or how do you want to store user tokens, or how the front end and back end should interact with each other. Like they still apply to both of them. Rather, what I want to focus on is what are the new architectural patterns that we had to implement to deploy the AI safely. So let's start with control. Prompt injection defense, this is very standard nowadays. We don't want malicious input to reach to our AI agent, so we use tools like Model Armor, and we have our own sanitization flavor on top of it to make sure that doesn't happen. Compute circuit breakers. We don't want our agents to run in infinite loops, so we implement token budget for every single step of the agent execution. So when the agent exceeds that token budget, it either moves to the next step or it just fails easily. And also, we don't want to open up for mask action execution. Because as I said, the user story agent will create those stories for the PMs. Now, we don't want a user to knowingly or unknowingly create thousands of user stories in a few minutes. So we put rate limits, like how many actions can the agent take within a given time span. And then the human in the loop gate. You can't mention that. Like, prompting is not going to help you make sure that when the AI agent needs to create a story, it asks for user approval. So we take that out of the AI agent's hand. Rather, we put deterministic guardrails so that whenever the agent wants to action on a critical tool, the system has to give the prompt to the user whether they want to take that action or not. The next thing is observability, end-to-end telemetry tracing. So we record everything that happens within a single interaction between the user and the AI agent, starting from system prompt, user's prompt, what tools the AI agent used, what were the inputs provided to the tool, what's the output of the tool, how it used the output of the tool to reason through its final goal, and then the final output as well. Because this helps us figure out when a bug happens, or the agent behaves in a manner that it was not supposed to, we can use the tracing to figure out the root cause of it, pinpoint exactly when it started. FinOps for the LLM, this is very important, and 2 points here. Number one, we optimize our token usage. So I think it's can't mention like things like skill, A2A, MCP, sub-agents. We use those when it applies so that we don't add all of that information in the agent system prompt. And that helps you with the token cost. And the second piece is the cost itself, because you have to be able to measure the cost to figure out what's the ROI of your AI agent. Because from a leader perspective, that's what they will need to understand. Like, I'm spending X amount of money on this agent, and the efficiency I'm getting from it, what is the final ROI? And if you can't track that cost, then in future, if you change your LLM, like if you go from 3.1 Flash to 3.1 Pro, or if you change your LLM provider, or if the LLM provider increased the cost of the tokens, you wouldn't have the ability to figure out how it impacts your ROI. And then the user context propagation. We adopted on behalf of execution. So when the AI agent is creating the user story, it's still the PM's name that's going to appear on the Jira story. It's not the agent's name. So that makes sure that the PM is still finally responsible to create the user story that the engineer can work on. And the final thing, which is probably the most important, that I have not seen yet people pay that much attention to, or they probably ignore it, which is testing the unpredictable. Any agentic system will have some risk associated with it, and that's because of the underlying non-deterministic nature of the LLM itself. It's non-deterministic, and There are many ways you can evaluate the behavior of the agent. Kanch mentioned a few ones like simulation. You can use LLM as a judge and everything. But that's very important, because unless you are evaluating your agent, you are not able to measure the risk level. And if you can't measure the risk level, then it's not production ready. And I'll give you an example. So if you think about the user story agent in its correct form, there is a human in the loop aspect to it. So even if the LLM goes rogue a bit, I can still accept that. I can still accept a lower level accuracy or a higher risk with my agent. But now think of a situation where I want to automate that workflow. I don't want the human in the loop. At that point, I would want to make sure that the agent is as accurate as possible. But even at that point, I need to be able to measure that risk. Because unless I measure that risk, the engineering and product leadership would not be able to understand what are the risk levels they are accepting. Because that's what they need to understand to figure out whether that level of efficiency they are gaining is OK with the risk they are accepting or not. And all of these evaluations, this cannot be one and done. You have to make sure that they are embedded within your deployment gates, because that's going to help you make sure that when you make changes in the future, your risk level are still similar or they have not degraded. So any drift that you encounter with the agent, you can capture that through your deployment gates. And if your agent doesn't meet the risk threshold, then it doesn't go to production. So, and that brings me to the payoff. Like we implemented all these new architectural patterns. Was it worth it? Absolutely. We tracked this across 3 KPIs. Number 1, high fidelity. We measured about the user stories that were created through the UI, through the user story agent, were about 24% better than the manual user stories created in terms of structure, level of details, and how that unblocked the engineering. Faster cycles. We took drafting from hours to probably minutes, and that helped PMs churn user stories faster. We observed about 40% improvement in terms of how PMs are able to create these user stories faster. And number 3, which is probably the most important one, consistency. Because if you think about the non-deterministic nature of the user story agent, one of the reasons is the variance in the input itself, because different people will ask the questions differently. But if you think about the output of the user story agent now, given that we have higher fidelity, which means more consistency, that will help my downstream agent. Because if you can control the variance in your input, your next agent can be more deterministic, because you know what structure you are going to accept as an input. So overall, we are not just writing stories faster. We are writing better stories, which leads to better product and faster execution. So I'll leave you with 3 takeaways. Prompting does not prevent non-deterministic behavior. You need hard deterministic guardrails around your agent. Number 2, govern the thinking, not just the output. The output is not the only thing that matters. You must have observability across the whole AI brain. And number 3, move from vibes to rigorous evals. Don't rely on it looks like it's working as expected. Have proper evaluations in place to convert those vibes with hard numbers, because that's what's going to help you make sure you can observe and control your future development. Yeah, thank you.